Here is a puzzle that nearly sank deep reinforcement learning in its early days. You try to train a neural network on the stream of experiences an agent lives through, one after another, and the whole thing becomes wildly unstable and refuses to converge. The experiences are just too similar, arriving in tight, correlated sequences, and the network overfits to whatever happened a moment ago. Worse, each precious experience gets used a single time and then vanishes forever. The fix that finally cracked it open is beautifully simple, and it is called experience replay. It is one of the two key tricks behind the famous DeepQ network. Let us unpack it. First, let us see the problem experience replay is solving. Train a network on each transition the moment it happens, and you feed it a stream of nearly identical back-to-back experiences. That correlated, sequential data makes the network unstable and prone to overfitting the recent trajectory, and each hard-won experience is used exactly once and then thrown away forever. This method stores each transition in a large memory buffer, then trains on a random mini-batch drawn from it. The samples are diverse and far apart in time, so correlations break, learning stabilizes, and every expensive experience can be reused many times over instead of being seen once. Here is exactly how experience replay works. Watch the loop. Every time the agent acts, it saves the transition, the state it was in, the action it took, the reward it got, and the next state it landed in into a large replay buffer holding many thousands of recent experiences. Then, to learn, it does not train on the single latest transition. Instead, it draws a random mini-batch from the buffer, mixing together experiences from many different moments across the agent's whole past, old and new blended into one batch. This random sampling breaks the correlations. Consecutive experiences were dangerously similar, but a random mix looks far more independent, closer to the well-behaved data neural networks are built to handle, and each expensive experience now gets reused across many updates instead of just once. That fixes both the instability and the waste in one clean move. Optionally, you can go further with prioritized experience replay, sampling the surprising high-error transitions more often. The agent then learns fastest from its biggest mistakes, focusing effort exactly where its own predictions were most wrong. Boil it all down, and three ideas carry experience replay. It stores past transitions and samples them randomly. Rather than learning from the latest step alone, the agent keeps a big buffer of history and draws random batches from it, so training data no longer arrives in a rigid, correlated sequence. It breaks correlations and reuses experience. Random sampling gives the network more independent-looking data it can train on stably, and each costly interaction gets squeezed for many updates instead of being seen once and discarded. It is an off-policy trick at the heart of DQN. Because old transitions came from an older policy, only off-policy methods like Q-learning can correctly learn from them, which is exactly what let DeepQ networks master Atari from raw pixels back in the landmark 2015 result. Alright, let us lock in the essentials. This technique stores an agent's past transitions in a memory buffer and trains on random samples of them, one of the two tricks that made DeepQ networks work. Random sampling breaks the correlations between consecutive experiences, giving the neural network more stable, independent-looking data, and it reuses each experience many times for better sample efficiency. It is inherently off-policy because old transitions came from an older policy, so only methods like Q-learning can correctly learn from a buffer of the past. Its main cost is the memory it takes and the choice of buffer size. A powerful refinement, prioritized replay, samples high-error transitions more often so the agent learns from its worst mistakes first. If deep reinforcement learning explained without the jargon is your thing, we have plenty more of it over at standarity.com. See you there.